representing a company called GEOMETRIA. And today I'm gonna show a few projects and under the topic of digital craftsmanship. A little bit about our company. It's a new company. We do design, parametric modeling, geometric rationalization, and fabrication modeling. So parametric modeling, scripting, algorithmic design. We are an architecture company, but we do, through specializing in the parametric modeling and fabrication modeling, we do a lot of consulting work for different architecture offices and engineering offices as well. Some of our work include the curved walls of the Museum of the History of Polish Jews by Lahdema and Mahlamäki architects in Warsaw. We took care of the geometry of the wall and all the fabrication data involved in that one. Some of the pavilions we've done in China for Mingmen exhibition pavilions. They're quite large, 60 to 200 square meter pavilions. And one of the recent projects we have undergoing is a commercial center facade in Helsinki for also Lahdema Mahlamäki architects. It's a quite huge facade, almost actually more than a kilometer long, comprising of ceramic beams here with more than 100,000 different ceramic beams. And actually, prior to coming here on Friday, I sent an Excel out to fabrication with information about more than 30,000 beams, separate beams, to send that to fabrication. And we actually spent more than 2 weeks just checking the information on that Excel. That's the face first, and that's the, one of the pictures I just received. So that's a part of this facade. But enough of that. A little bit about my idea of digital craftsmanship. And through the methods of digital design, the designers are becoming digital craftsmen, kind of doing things by hand digitally. It's a topic well known here in FabLab, but it affects the design field as well, quite well. In digital design here, I refer to things not just design done inside or with the computer, but design done computationally, utilizing algorithmic design, algorithm-aided design, generative design, parametric design. They're kind of all the same, meaning all the same, but we have different names for the same subject. So digital design is not just using your mouse and a computer screen. It's actually what was represented quite nicely also with the Quartet Mignon presentation, that we kind of utilize the computation power of the computer more intelligently and produce processes that aid us in the design. And as a designers, we are taking control of the process from the design to fabrication to assembly. So instead of just producing 2D paper images, we're actually taking control of the whole process from the end of the designer, from the design, the computer screen of the designer to the actual digital fabrication, and from there on to the assembly, as well nicely put in the Wiki House project also. So with our new methods in design and fabrication, we can create more complex design processes, something like here done with Nila's sculpture we did for the Venice Architecture Biennale, where we, very simple algorithm utilizing mesh subdivision and some Catmull-Clark mesh smoothing, created very complex design patterns, testing out different variations with that very simple process, creating out of a simple process, creating very complex shapes, very naturalistic, very organic shapes, and selecting a method for fabrication and then producing some kind of artifact for that exhibition. or we can utilize biology, get inspiration from nature, and utilize that in our design processes. Because nature works in a very efficient way. We can kind of simulate the natural growth processes of trees, for example, simulate that in a digital environment and create structures mimicking the effects and taking advantage of the benefits of those types of structures. Here is a Gila Pavilion from 2009 using a digital L system or Lindenmayer system developed by a Hungarian biologist, which simulates the branching structures of a tree. So we created this kind of a structure on top of a surface, and we're able to fabricate these types of elements. The fabrication happens completely from a digital file, so only 2D prints are necessary for the assembly. It changes the way how we build, how we distribute information out of our designs. Then prototype assembly is kind of looking like a puzzle, and assembled at the courtyard of the University of Oulu Architecture Department in 2009. Here. That's actually a photograph, that's not a render. It's a really good photograph taken by a friend of mine. Here is an exhibition structure for Liminality Nature Center, commissioned by a friend of mine who did the exhibition itself. It's a sliced plywood structure, reminiscent of a breast of a bird. For the subject of the theme of the exhibition was birds of the season, birds of that area. And we developed a method for creating that kind of a structure, and then how to create created the joint, how to assemble that structure, divide that into elements ready for the sizes ready for fabrication, taking into consideration the sheet size of plywood and the measurements of, let's say, a doorway that you can carry those things in, and everything we have to design in a digital process. So we start with a design, start with some kind of base surface, create the process that creates the structure itself and apply it to that surface, creating a lot of information in the form of CNC milling information in the form of line data, and gathered here. See a piece of that one in construction, ready-made for a piece of, for this one little wall here, reminiscent of a broken egg. That was part of also the theme of the exhibition. Here it's ready. And also did the furniture there with the same type of structure, detailing and assembling these types of organic shape structures. Information, 2D information here was created only for assembling instructions for the carpenter. So everything else happens in a completely digital environment. You design the form digitally, you design the construction type, the construction details, and all the information passes from the designer to the fabricator in a digital format. So when you model, when you design something, you model it exactly. You don't create some kind of rough concepts that somebody else translates, but you actually do very accurate modeling work. And the methods of parametric design, the methods of algorithmic logic allows you to create very complex yet very accurate models that can be later on fabricated. So it's a full-on process. I'm going to show you a couple of pavilions we've done from wood. This one is Gila Pavilion done at the University of Oulu with the help of students and the help of DigiWood Lab project. We had a 5-day student workshop where we had an idea. After that workshop, we had an idea of a form. We had an idea of a structure. So the form is a cube, which is where there's a void carved outside of that cube. And the idea of a structure is that kind of a 3-dimensional wooden lattice structure. It was manufactured with actually the same devices that are used in the Finnish log industry. So the same devices that are used to create log houses, very traditional log houses, can be used to create new types of architecture. They are very efficient machines, but they are used, kind of underused in a very traditional way, in a very traditional log joints. So creating a parametric script here, the whole pavilion was created in the script, allows us to modify very fast. If there are changes, we can modify them within seconds, find different variations of that surface, of that shape, of different structural dimensions, structural grids, and then when we're satisfied, it's ready for fabrication. As this process here, explained on the right side, shows the script that generates that shape. It automates the process. It allows us to simultaneously, while designing, be informed of different analysis, different lengths of the beams, whether they are too small or too big for fabrication, the amount of connections between beams. And the designer can simultaneously, while searching for the right form, searching for the right structural grid, simultaneously be aware of the different properties of that grid itself. And of this, the same model can be sent to for engineers for structural analysis. It happens quite very fast. All happens very fast, and this was a very fast project. We had actually only 4 weeks, and within 4 weeks we from design to the part where we had ready pieces of wood on site. So it took only 4 weeks, and 1 week was reserved just for fabrication. So the design phase of this was only 3 weeks from scratch to the part where we sent things to fabrication. So we assembled this in 4 days in the city of Oulu on the shores there. Received more than 400 different pieces of wood there. That came by a truck there from the fabrication manufacturing department, and we started to assemble it. No power tools needed. All the holes, all the connections were already present in those pieces. It was like a big puzzle. We constructed the thing in 4 days, 4 working days, and there it still lies. These pictures are in 2014, and it's still there. Nicely grayed though now, but the structure itself, it's very lace-like within the building, within the pavilion. It creates these very nice lace-like shadows in the ground, and the outer shell is a little bit more dense for creating a little solidity in the object itself, and also to prevent climbing, because drunken students are a big issue in Finland also. The next pavilion I'm going to show is a Bauhu pavilion, constructed last year for the Tampere Architecture Week in Finland. It was commissioned by the Architecture Week to create exhibition space within the center of Tampere. That's one of the central streets there, and they had the theme of interaction, and the city of Tampere had an ongoing project to liven up that street, to get some entrepreneurs working there, get people to stay on that street more, because it was before just reserved for traffic. There's still buses going there, but no private traffic is anymore. And they wanted to develop some kind of stage for people for impromptu exhibitions, impromptu shows. People can reserve that from the city and have presentations or something within the city itself. The shape of the pavilion is inspired by the rapids going through the city of Tampere, and also from the sculptures of Finnish artist Tapio Virkkala. So the concept is quite simple. We have a cube. Within that cube we will form a line. This is also defining the process of how the form is created. And within that line, a stick or a line is rotated 170, almost 180 degrees around that line. Very simple shape, and it gives out this kind of two-way curved surface that is then dissected from the cube itself. Structurally, it's very simple. It is a very traditional structure inside. We were also in a very limited budget, and we tried to minimize the use of CNC, because that took time, that took money. So we tried to create an organic shape, a very kind of still a showpiece in the center of city with limited budget and very limited CNC. So the structure itself, it's a box. It's a very, very traditional, very simple structure. And inside that we have arch combs that hold these kind of plywood strips that turned 180 degrees, creating this kind of a doubly curved appearance of a doubly curved surface inside the pavilion. I'm going to show up a little model here of the pavilion. The appearance of the surface inside is doubly curved, but it's actually made of very flat and straight pieces of plywood. And here you can see that the structure itself is very simple, nothing out of the ordinary here. So we had to make sure that we are able to manufacture and assemble the whole thing in very fast time. We took about 9 days to get the thing completely ready and shipped on location. Let's see if I can find a section view here. These strips overlap differently within each other, and the sizes of these are optimized in a way that we minimize the use of plywood here. So they are taller in these edges and smaller in the center where the rotation is smaller. These arches themselves are done with from 2 or 3 pieces connected with this kind of a jigsaw connection, which proved to be very efficient and very sturdy connection between these. Let's see. I haven't used this LibreOffice before. Let's try if it works as in Office. Yes. So we constructed that offsite in a course of a little bit more than a week with the help of a student workforce. Here you can see the strips made out of simple plywood, and these are actually the only CNC milled part in the structure of the pavilion. These plywood strips connect to these notches in the strips, and they are made out of 2 or 3 pieces with this kind of jigsaw joint. And during the Tampere Architecture Week, we had several presentations, talks, people singing, doing DJ gigs there in the center of Tampere. And it worked quite well. It's a very nice backdrop for the presentation and from the presenter. Here you can see the strips from the side. And there's also LED strip lights on the floor. The facade of this pavilion is clad with this kind of 3-dimensional wood panels, which is a product development I've been doing with a company called Jukola for the last year and a half now. We haven't been quite in public with this yet, but we've been busy doing product development, and we're launching the product within this month, at the end of this month in Finland. The idea came for this product from the idea that what we have now in timber products, in panel products, are linear profiles cut from one direction. So that limits us to a certain degree of what we can do, because they're linear products. You get the same profile through the entire board. Working in collaboration with Ciparella, of course. So developing a method for fabricating cuts into the panels that are not linearly cut but perpendicularly to the wood, a very efficient cut method where we have the wood and we slice it through very fast, very efficient in industrial speeds. So something you can do with CNC, but with very kind of, we can produce this much faster. With this new type of cut method, we can create different types of patterns for wood. It's a very simple process, and we can process these very fast. We can create these kind of shingle type shapes or even more complex shapes. It's based on the same and simple cut method that now provides us practically unlimited amount of different types of patterns that we can create on wood. So, okay, we have a lot of these variations, and these are just kind of a few of them, and these are only what we kind of come up to here. Constant product development, constant work with designers. We can refine, we can create different types of cuts. And when we have this effective cut method that we can create repetitive textures, repetitive patterns, we have digital tools that allow us to control this whole process digitally from the design to manufacture. We can create these types of logos, these type of texts, writing, taking part that is textured to a part that is not, And also from that, which is kind of a black and white image, we can go into grayscale. Finnish athlete Paavo Nurmi, then transfer to wood panels. This is not a render, it's not a print. The whole image is formed out of different cuts. The deeper the cut to the wood, the more shadow you get, the more darker image you get. The lighter parts, you have no cuts at all. So all of this is done just simply with shadows. Some developer of the cut technique, and this allows us, when we process a single board at a time, it allows us to be fast. We don't work a lot. It takes a couple of seconds to work on a single board. We can produce big areas very fast. This is actually a done project, but I don't have a picture of the finished thing. But we can produce wooden facades that have images on them, okay, texture, but there is no limitation to the size, because only limitation is the length of the board. So if we can process a board, then the whole facade is comprised out of several boards, and so there is no limitation to the size what we can do. And for instance, this is in Pieksämäki, Finland, there is this old railway station that was converted to commercial use, and they wanted a picture of their locomotive there as a reference of what it was there, what was the history, and they still have actually that locomotive. And that's kind of the screen capture from the software itself, testing out, simulating what it would actually look like on site, done with rendering of that image, no prints, no textures, and then what it looks like on site. So it's very much matching to what you see on screen to what you see on real life. And again, all these images are made out of just the shadows in the wood. And here is a new picture coming to the housing fair later this month. So it's not assembled yet, it's fabricated, but it's not assembled yet. And so I can only show you the 3D model of this one. But here you see the process, here you see the kind of simple procedure that the whole image is made out of cuts in the wood. It works better in larger surfaces because basically the width of the board is your pixel. So more boards you have, the more resolution you have to your picture. It's also a view of that. So, okay. I thank you. Merci beaucoup.
Donc merci à